Good morning, everyone. For those who don't see the chat, we're taking a poll for where people are joining us from. Would love to hear from you, but we do plan to start at 10:03 just to let folks join.
We should say 3 after the hour. Who knows what time zone you're in? 10:03 is Pacific.
We'll be starting in a couple minutes.
Yes.
All right. Good morning, good afternoon, good evening, everyone, wherever you're coming from. Looks like 65% of people are coming from North America, so should be a mix of good morning and good afternoons. But we've got folks from all over the globe, and we're really excited to have you here today. We have a few housekeeping items first. We have collected questions up front as part of the registration process, but we're happy to collect questions in the chat, and hopefully we'll have time to get to them, but do realize that we did receive a large number of questions, and we'll try our best to get to all of them, sometimes even after the call. This session is being recorded, and we'll share links to the recording and the deck after the event, and we'll even try to drop it into the chat. And if you want to connect with Ronny, you can find him very prolifically on LinkedIn, dropping all sorts of interesting and important advice and tips on experimentation. I'm also there as well if you want to connect with me as well. But let's start. Our guest today is Ronny Kohavi, and a man who needs no introduction if you love experiments. Ronny's career is long and distinguished and has been a data and experimentation leader at companies such as Amazon, Microsoft, and Airbnb. He's also the co-author of a book called Trustworthy Online Controlled Experiments, which has become very much a fixture on the desks here at Statsig. So Ronny, we are very excited to have you here today. Welcome.
Thank you very much. Pleasure to be here.
All right, let's get started. I have two questions to start, and both of these are on the topics of small sample sizes. They're from Notion and Hero. Notion asks, any advice to share about experimenting on lower volume surface areas where only large effects are reliably detected? And Hero has a similar question, which is, what are the best utilizations of A/B testing when your population size won't produce stat-sig results?
Great. So let me answer this. The first thing I want to say is it's important to realize that there are necessary ingredients for running A/B tests. So there are times and situations where A/B testing is really useful, but you also have to recognize that there are cases where it's not. So I'm going to go through these 4 ingredients. The first one is you have these experimental units. Mostly they are users, but some people randomize by pages or sessions or other randomization units. And the assumption is that these can be assigned to different variants with little or no interference. Okay, the second ingredient that makes A/B testing really useful is that you can make changes easily, right? So in software, we have this magic where it's trivial to change it. If you go in the hardware world, it is much, much harder. The third ingredient is our control our ability to define what we're optimizing for. So you have to think about the key metrics, and ideally there's something called the OEC, your overall evaluation criterion, that the organization can agree upon and which can be measured effectively in an experiment runtime, so in a few weeks usually. And then the last ingredient, which is I think what the questions are mostly referring to, is do you have enough units, enough users in most cases, so that the math starts to work out. So there's a statistical formula called the power formula that allows you to plug in something about your metrics, your variance, and what you're trying to detect, the minimum detectable effect. And then it spits out the number of users that you need for a certain level of confidence. Usually we assign 80% statistical power. So I'm going to give you a rule of thumb. And that rule of thumb says, look, you can start off with tens of thousands of users. But if you're doing something like a retail site, which has a low conversion rate, retail sites usually end up around 2 to 5% conversion rate from users to purchases. You're going to really need about 200,000 users in order to make all this magic work out really nicely. So there's a link there that Morgan put into the chat. If you're interested, there's a talk I gave on what I call practical defaults. And that helps you understand when you can go from, I don't have enough data, I'm not going to be able to detect things that are useful, into a mode where the magic happens and you can start evaluating your ideas. And that threshold starts at high tens of thousands, ideally 200,000.
Yeah, I really like those rule of thumbs. I do have a question over if you perhaps don't have tens of thousands, let's say you've got like 5,000 users and you know you are challenged for statistical power. Is it still worth running an experiment, or would you not consider it in that case?
Yeah, so you have to make your own trade-off. You may run the experiment looking for very large effects, so you may not be able to detect an effect of purchasing, but maybe you'll settle for another metric, which is clicks or add to carts or something like that. The value diminishes materially because you're not judging the idea by the thing that you really care about. Other things that I recommend when you're a small startup is just go for best practices, right? The Amazons, the Microsofts, the Googles of the world, the Facebooks, Meta, they've run the experiments. So if you look at how they design things, how they have built things, the flow, the user interface, those are good ways to start until you can have enough traffic to try it on your own.
Super helpful. We received a lot of questions on experimentation culture, and so we've selected this one as probably a representative one. The person asks, how can data science leadership build a strong experimentation culture within the company?
Yeah, so great question, discussed heavily in the book and in my class. And I think of this as like a 4-stage progression. I see groups of or companies that sometimes have this hubris. We know everything. We don't need to test anything. And then they start to go into measurement and control, saying, hey, do we really give the users what they want? How many users use the features that we're really providing out there? So, and then they start to see this sort of this humbling experience that most ideas fail. Funny story, I ran several teams at Amazon, including recommendation, and we were using a tool for experiments called WebLab. And then, I was the first to sort of collect the statistics there, and I realized that, more than half the ideas that we tried in Amazon failed. When I then moved to Microsoft, there was no experimentation going on, and I was trying to pitch this and say, hey, 50% of the ideas at Amazon were failing. Just imagine if we could evaluate the ideas here and have the data. And the typical response was, we have better program managers here. So there's this denial phase where people don't really believe that they're wrong so often, but the data is very, very clear about that. So then you get the third phase, which, people start to run experiments, and sometimes there's this disbelief in the results. Now you have to, first of all, sometimes say sometimes it's true. Not every experiment that you run should be trustworthy. You have to go through some set of tests. You might want to go through replication, but I've seen this over and over again where there's some result that conflicts with a strongly held organizational thought, and there's this disbelief. I mean, I'll again, another funny story from Amazon. Jeff wanted us to make some UI change. He was very sure of it. It came back very negative. He says something is wrong with the system. Do an audit. Now we did the audit. We came back and we said, no, we believe this is right. And he, updated his belief, but that can happen. This Semmelweis reflex comes from the medical community, by the way, where Semmelweis was a doctor, was the first to sort of discover germs, and nobody believed him. Great story there. Won't go into that right now. And then the fourth phase, which is very hard, we're not there in many areas, is this fundamental understanding. Do we really understand how to build something? In some areas we do, in some others we don't. You think about mobile, I think the literature is very mixed about how to build a good mobile experience, given that you have a small amount of real estate. So given the question, I want to say things that I've done that were successful, and you can take that and morph it to your needs. The first one is sort of in the company, find this beachhead. It's a group that meets some of the necessary ingredients of being able to use experimentation heavily. So for example, they need to deploy often, right? You can't, if the group deploys daily, multiple times a day, or every few days, or maybe even up to every 2 weeks, it's good. Right. When I started at Microsoft, Office sort of changed the product every 3 years. That's not a good place to experiment. Second thing is make sure you have that clear OEC. There's some products or groups where you can define, here's what I'm trying to optimize for, and everybody agrees. Others, they're harder to do. Okay. And then with that beachhead, if you can run experiment and start showing surprising results that are useful, start showing progress, then you can start expanding from that one group to the rest of the organization or the company. Second thing that I like to do is just education. Teach people what the pros and cons of experimentation are, the ingredients, and then share examples from other companies, right? Tell them, hey, look, most companies are not able to get the success rate above 30%. Right? It's kind of humbling, but the success rates have been reported from around, 8%, which I reported at Airbnb search. So only 8% of our machine learning modifications and modifications that we did for search were able to actually improve the key metrics we cared about, all the way to about a third or 30% overall at Microsoft. And there's all these in the middle where people are reporting 15, 20%, 10%, but it's very humbling. So make sure people understand that, it's not that our success rate is 80% like most people think. We're very, very low, and it helps to educate from other organizations. We use this little mascot of the hippo. It's a little toy that we made, stands for the highest paid person opinion. And we gave thousands of these at Microsoft just to remind people that, we want to empower this hippo with data and make more data-driven decisions.
Great. I think the only thing I would sort of add to that is that I think if the beachhead and the OEC is matters a lot to the company and has visibility company-wide, that's a great way to sort of spread experimentation. Right. Yeah. All right. Next question.
Okay. Next question.
This question is from Hato Batako, and we got lots of themes on this question, and I'm not sure which stage this sort of question would come from in the previous framework, but how do you create a culture of experimentation when your experimental results are usually inconclusive?
Yeah, so first of all, you have to make sure that when you say your results are inconclusive, do you have sufficient statistical power? Right. And what I remember, what I said by power is you can plug in your metrics, you can plug in the minimum detectable effect that you want to detect. I want to detect changes that are 5%, and then it tells you the minimum number of users. So if you're telling me that most of your experiments come back inconclusive, it may be that you don't have enough statistical power to be able to detect the changes that you are doing, right? But if you do have enough statistical power, and the experiments come back as not statistically significant, or what we call flat, then you learn something. this idea that you've implemented and just launched does not improve or hurt that overall evaluation criteria a lot, right? Based on the MD. So if you're able to detect a 3% change, then you know that this change isn't more than 3% in either direction with very high probability. So I think there's a lot of learning from that. And realize that it does happen. I mean, it's not unusual for even, large organizations. I worked several years at Bing, where we have ample power, lots of users. We could detect things like a 1 millisecond degradation in performance. But, a third of experiments came back as flat. And that's okay. We learned from them that this idea isn't as good as we thought.
All right, we're going to do a quick lightning round just to sort of like capture a bunch of the culture questions. So this question is from Coding Ninjas. Are there any big changes that you don't do A/B testing on?
So first, you have to realize I gave you the necessary ingredients, and not everything can be A/B tested. But if you can, and in the software world, I think it should be super rare to use other methods. Now, there's a couple of things you might say. One, it's possible, and sometimes I've seen this, where the cost of an A/B test is going to be so high because we have to, patch DOS or do something. It may not be worth it. So I see that case happens. It should be very rare. And then there are some cases where, due to interference or other reasons, you may want to use some other evaluation mechanism, a quasi-experiment. And there's lots of literature on how to do these. They're not randomized. They're not as reliable as a randomized controlled experiment, this A/B test, which is at the top of the hierarchy of evidence. And you have to say, we're going to do this quasi-experiment. It's going to be less reliable. Possible, but I recommend that, my rule of thumb is, if you can run an A/B test, drop everything else, do the A/B test, because that gives you the highest reliability and trust.
Great. This question is from TXI. What is your biggest challenge when beginning an experiment?
So I think one of the challenges that I see when people start is make sure that the hypothesis and the implementation details are documented. Okay, why? First of all, from a statistical perspective, you have to decide in advance what the hypothesis is and how you're going to measure it. Don't adjust things once you start to see the result. But I think more important, and this is for institutional memory, you want to know that 6 months down the road, when somebody says, hey, did we ever do X? And then we find this experiment that touched X, can we look at the results? Can we look at what was done and what did we learn from it? And I think that's a very hard challenge to convince people to document what they're testing and what are the implementation details, like screenshots of a UI change or explanation of what you did to the back end, so that, a few months down the road, somebody can look at this and reanalyze or, learn from it, and do other things. So I think that's very important.
Great. For this person, stakeholders interpret data-driven to be that data eliminates uncertainty. How can we best communicate uncertainty?
By the way, the question included the not true parenthesis. So the person asking this doesn't believe it, but he's asking how to best communicate uncertainty. So first of all, I agree. I think, data doesn't eliminate uncertainty. I like this framework that Doug Hubbard has on EVI, the expected value of information. So he says, the more work you do and there's cost to discovering something, the more value you can get about your question. But, to me, the p-value that is very commonly given in any experimentation system, including Statsig, of course, it's evidence. It doesn't mean that, something is true or not. We can only tell you that something is likely true with high probability. So sharing that p-value and explaining what it means. And the confidence intervals is another way that sometimes it's easier to share people. You tell them, look, we think this idea is worth 2%, but we're not very sure because the confidence interval is between 0.5% and 3.5%, right? So that gives the people the variability in the result. I assume most people might know that if something is statistically significant, say at 0.05, then it means that the 95% confidence interval does not cross zero, at least, so that you know it's positive, but you don't know where it's going to be. We have a mean, and then we have this confidence interval that communicates that uncertainty that we have in the data.
Great answer. You walked around the p-value and confidence intervals nicely. This question is about incremental versus strategic testing. People often use A/B testing as a straw man for micro optimization. Do you have some examples where like A/B testing made a dramatic shift in strategy?
Yeah, so first of all, I think it's a fallacy. I've heard it a lot. People will say A/B testing is good for incremental changes only. I've seen A/B testing used for everything. Of course, from incremental, most organizations spend, most of their effort making adjustments to their current product and improving it. I call this sort of the step-by-step, the inch-by-inch movement that we're often surprised at the end of the year that we did all these small things, but hey, revenue, if you add them all up, revenue increased by 15%. That's a real number, by the way, that we did at Bing. Every year we used to kick revenue 15%. And most of the time, these came from very small incremental changes. But I've also seen A/B testing used for big strategic changes. And the person asked for examples. So here are two examples. I worked at Amazon. We were initially at Amazon selling only first-party products, right? Only what Amazon had stored. And, because of eBay, we saw that, hey, it may be useful to allow other people to sell stuff. And so Amazon initially implemented something equivalent to eBay, but it was a separate page. And so it was called merchant pages. But then the discovery problem was hard. How do I find a product that I found on Amazon on these merchants pages? So there was a decision to implement a single detail page that combined both Amazon product and any third-party merchants that wanted to sell it. Now, today, you may think it's sort of obvious. At the time, it was heavily debated whether we're going to mix it, what's going to happen to the reliability, but that was a strategic change. Amazon ran those experiments and saw dramatic improvements in the single detail page implementation, so it went there. I'll give you a negative example, which is at Bing, we tried to integrate sort of social, meaning you type a search and we would say, hey, here are some of your friends from Facebook and Twitter, now called X, which have asked similar things that are related. We spent, I think an estimated 100-person years on trying to integrate social, so hundreds of millions of dollars, and nothing was useful. So we had a strategy. We were making a big bet. We announced it. We invested heavily in it. We used A/B testing to inform us that this is not useful. And, a long time, this was a slow, instead of a fail fast, it was a fail slow. This whole feature of the third pane was removed. So I definitely think that A/B testing helped us see early on that the strategy is not working. And as we got more and more data, there's always the question of, am I going to get the home run next week with this new idea? We were trying a lot of new ideas. None of them seemed to work. And so the strategy failed. And we were well informed by A/B testing throughout this process, how things are going.
One thing I really enjoy about talking to you is that you have like such a depth of war stories from experimentation. And I'm just curious if you just have a quick thought on like why, if you look at the A/B testing literature, do we see so much publications on micro optimizations and not enough of the big ones?
I think it's an effect of giving talks that are great. I do the same. I go and give a talk. What do I share? I share sort of, look, this group made the following trivial change and got, massive improvement, right? There is this thing where we want to show the most extreme examples that people can understand. If I go and I have to tell you a very complicated change, I'm going to lose all the audience by, the 10 minutes that it takes me to explain what was being done and why it was strategic and what happened. It's much easier to pick sort of a tiny change that is so surprising that everybody thinks, this isn't going to do anything, but it makes a large change that I think it's our own fault. We highlight those examples in presentations. And then people think, oh, so A/B testing is only good for changing button colors. But I don't think that's true.
Thanks for that.
Maybe I'll answer. There's also Steve Cyrick says, why did Ronny become so passionate about experimentation? He really goes out of his way on LinkedIn and elsewhere to communicate his message. I'm curious what motivates him so much. So this is related. And I'll tell you why. I started my my life in sort of machine learning. I got my PhD in machine learning from Stanford. I went to work at Silicon Graphic. We built a nice data mining and visualization product. And it was great. We had all these like great discoveries, which companies promptly ignored because they come from left field. They're not part of the product team. The nice thing that I love about A/B testing is you're embedded in the product team. You're helping them test their own ideas, and you're able to adjust the roadmap. And I think the influence that you get from being a data scientist working on experimentation is so much higher than if you sit on the side in this ivory tower and look at the data and come back with interesting findings. Because when you come up with an interesting finding, they'll say, sure, we'll look at it once we finish all these more important things on the roadmap. And then that you look at it and you say, wow, this is going to take 2 years before they're going to test my idea.
I love that. I've got another question here. This one is from ViralBank. What was the most subtle change to an experiment setup that ended up greatly affecting the results that you have seen?
Yeah, so as I said, there's lots of talks about this. My book starts with a nice example of a subtle change, but I'm going to pick something else which I think had long-term sort of industry implications. And this was this idea that you would open a link in a new tab. And I'll take you back. This is, back to 2008. Nobody was doing this. A link opens in place. And if you want to open a new tab, you right click and you say to the browser, I want you to open this in a new tab or window. So there was a proposal to make this change so that this was on the MSN website in the UK. So not even where we were running most experiments in the US. There was an attempt to change this by a person who proposed this in the UK. And there was amazingly strong resistance. Designers said, no, this is not nice. People, have an option to right click and open a new windows. Nobody's doing this. We have an industry standard. The browser, when you click, opens in place. But we tested it. And we tested this on opening the email, the Hotmail, it was called at the time. Now it's called Outlook. But it was hugely beneficial. So now all this data came in. Wow, this increases engagement a lot. People open their Hotmail in a new tab. They read their email. When they're done, they close that tab. Boom, the browser goes back to MSN. Now they see headlines and they read headlines. So it was massively impactful to MSN. There were some concerns there, I'm not going to say, nobody complained. We got feedback from users, just like the designer said that, hey, if I want to open a new tab, I'll right click. But it was so low relative to the value, we launched it. And now the reason that I like this example is you can see how progression moves slowly in an org. It took 2 years after this amazing success for the US site that, again, resisted this change because of industry conventions to implement it in the US. It had similarly surprising results, and it was immediately shipped.
This is a great example because it's just like that was industry standard. And now
right.
it's interesting now,
Yeah. And then again, look how slow things go. Then this, remember when I talk about institutional memory, we were starting to discuss this inside Microsoft and MSN as an amazingly good example of something that's not intuitive, goes against the standards, yet the results were so beneficial. We ended up shipping it in 2 countries and then, of course, worldwide. So 9 months later, again, look at the time gaps. Okay, we started to say, wait, maybe we don't just open Hotmail. Why don't we also use this for search? So if you're going on MSN, there's a large search box at the top. If you search, we're going to open that search result in a new tab or window. And it was massively successful. Just to give you an example of a metric that we disclosed in paper so I can talk about it, we had a 5% increase to clicks per user on MSN, right? They're so thankful. Like, this doesn't happen for years that you can get an experiment that's so successful. So then, you can start to see industry adoption. We talked about it at conferences. We gave, I remember, a tutorial where we share this. And you can see, Airbnb ran this experiment and, of course, implemented it. You can see it right now. Facebook, LinkedIn, everybody's using this convention now, that people are now, when they see this example, they go, really? Like, it used to be that you never open in a new tab or window. So I think that's a great example of it. So, and subtle change, remember this, how subtle this is. This is like one line code change, right? Your little link has to have a one line code change to say window. This is also a pattern that goodui.org has shared. I recommend this site for people who want to look at patterns. So Jacob Lanowski has this site with patterns, and he gives sort of evidence when people replicate an idea and share the results. Now, I'll end with, you need to be careful, right? Because once we had these things, people said, wait a minute, why don't we just open every link in a new tab? And so there was an experiment that was run to open every ad in a new tab when you search. Remember, when you search, you might get 1 to 0 to 3 or 4 ads. They wanted to open in a new tab, and it was actually a small improvement to engagement. But this is where the OEC encapsulates other things, and we thought this is overdoing things, and we decided not to launch this.
Great. This is a question about, we had a few questions on real-time experimentation and monitoring results as they come in. But this question specifically is from PayPal. Are there instances where early stopping is right?
Yeah, so I think early stopping is critical. I'll just say, I think everybody should implement this, but you should only early stop to abort. And I think that's an important distinction that a lot of people miss. So instead of assuming that you're running an A/B test as a single test, you're hoping it'd be positive, but it could be negative. You can run this as what's called toast, 2 one-sided tests. You do one-sided test to see if it's positive, and you do one-sided test to test if it's negative, if it's hurting. And when you think about it that way, the positive tail could be a normal A/B test using the standard statistics of a one-tailed test for positive that you test at the end of the experiment. But the negative tail, am I hurting, that could be implemented with more sophisticated sequential testing, so that you lose some power at the end. Maybe I'm not going to be able to tell you that it degraded by 3%. Maybe I can only tell you that it degraded by 4%, but I can abort early. And the reason the math works out so beautifully is that if you're running an experiment, saying you have an MD of 2%, meaning you're able to detect a 2% increase or decrease to the OEC. Now, if it degrades, the experiment degrades something materially, I have a serious bug. I'm hurting this guardrail Statsig, or I'm hurting my OEC by 10%. You can detect that really early. Okay, so in this example, we went from 2%. I'm looking for 2% effect, but I hurt the OEC of some guardrail by 10%. The formula for power has this ratio squared. So if I'm looking for an MD that's 5% larger, right, the 10% versus the 2%, I don't need 5 times fewer users. I need 5 squared, or 25 times less users. So if you think about it, whereas I planned the experiment for 2 weeks, I only need a day to detect a 10% degradation, right, for the same metric. So this works so well, because if you have an egregious issue, you can abort it really early. So my recommendation is, think about aborting early on the negative side. Don't abort early on the positive side. Now, some people do that. I can point to Georgi and his book. There's a whole area of futile where you can say, I don't need to run it anymore. It's already big enough. I can stop. But the problem is it tends to exaggerate the effects. So you don't get a good estimate of the effect, and the reliability is not as high. So I do recommend for the positive side that you go all the way to what you plan and get the statistical power that you can. There's a link about this if you're looking. I see that Morgan just put this in the chat, so that's great. So this explains my thinking about this if you want to get deeper and understand it.
Got it. I was wondering if you could just sort of double click on that last point there. Can you comment on the use of sequential testing, especially some of the more popular methods when trying to detect and make a decision on positive effects?
Yeah, so there are several ways out there. One is always valid p-values, where you're allowed to peak as much as you want, and the error is controlled. I'm not a big fan of that. And the reason for that is that you lose statistical power. So instead of being able to call the experiment at a given MDE after 2 weeks, I may have to run the experiment for 3 weeks. And I think that trade-off, I may be able to abort early. And indeed, some of the authors, Ramesh Johari and others, have papers showing that in some cases you're able to abort early. So there is value in this always valid. I think the most interesting case is the thing that we lack the most is power. And I don't want to make that trade-off. I'd rather run the experiment for a few more days and have a solid result at the end that has more power than being able to call something early when, if I can't call it early, I may have to run it for another week to see if I can get the same level of power that I could have called before. I also like the predictability. We plan an experiment. We plan to run it for 2 weeks. At the end of the 2 weeks, people know there's a meeting set up. We can actually look and analyze the results. So I'll say it's debatable. Not everybody in the industry agrees with me, but that is currently what I think. And I think most of the large organizations that I am familiar with, whether it's Microsoft and Google, most of them have adopted this approach of fixed horizon for the positive tail and sequential testing for the negative tail.
Thank you. All right, next question. Big changes. What is the best way to test a completely new experience as opposed to testing a series of incremental optimizations?
Yeah, so another great question. And I love it because I just wrote something about this, which is most redesigns fail. And I think Morgan will put the link, but it's a recent post. You're welcome to read it. But I basically give a lot of evidence. So there's two things that people miss. One is the success rate. Remember that, somewhere around 10, 20, 30%, let's call it 15 to 20% success rate. If you agree that you can't even predict the success rate of small things that we're doing in A/B testing, those 2 week experiments, what is the chance that you're going to get a major redesign where you lump 30 of these together, where you're going to get this correct? The other thing is people describe sort of the surface as we're on a hill. We did hill climbing. We're probably at the top of the mountain. So let's try to jump further away and hit a bigger mountain. The problem is, one, we don't know what the landscape looks like. It may be that, taller mountains are really hard to find. And the second thing is, when you jump far away, you may not jump to the top of another mountain. You may jump to some valley. And that's why we see in practice that a lot of redesigns fail. And again, this post gives a lot of evidence that this is not going to work out. So what I think is better, in my humble opinion, is plan for a major redesign. Do work on, this is where we're going to go, paint a nice vision of where we want to go, and then start moving towards it in steps that you can decompose, right? So I do agree, sometimes things interact and the designers want to do 2 or 3 changes together. Go for those. Don't go for 30. Because what's going to happen is when you run the 30, it's going to fail and you're not going to know why. People come back to us after a major launch and say, well, it failed. Now you're the data scientist. Tell us why. Well, I can't tell you. You did 30 things. But if you do a small set of changes, we can say, okay, this set of 2 or 3 changes was successful, ship it. This set failed. Let's try to replicate this with small changes and maybe try to isolate the factors or do a multifactorial design where you can actually analyze 2 or 3 factors. You can't do this with 30. Okay. I want to give this example because what I tell you in sort of the middle column is effectively what we did at Amazon. We had these long plans to morph the page, but we were testing them on the way. If you think about Amazon, it never does major redesigns. You rarely, if I worked at Airbnb, it's like every 6 months, boom, there's a major redesign. In Amazon, everything works in continuous evolution, which I think is a much better way to do this. And when people say you're only going to do micro optimizations that way, I want to show them this page from Amazon in the early days. Amazon got from this page, right, to the page we are today through A/B testing all the time on the way. This page, the first Amazon page, doesn't even have a search box, right? And there's all these experiments on the way where the search box was introduced and then moved initially to the left and then realized, wow, it's more important. We should move it at the top. And where does it stay at the top? All these experiments, each of them improve things. And so, Amazon is a very, very innovative company, but it tests things on the way. And I think it's something you should point to if you're trying to convince your org, or if somebody claims that A/B testing is only appropriate for incremental changes.
There's like a slightly relevant question in the Q&A chat, and it's like, do you think Elon Musk A/B tested the name change from Twitter to X?
I think the answer is simple, right? No. Move on.
Good, just confirming. This question's on concurrency and interaction effects. Do you recommend having multiple tests running on the same page of a website? And if we have to have multiple tests, what should we do?
Yeah, so first of all, I think the answer here is very simple. Yes, I strongly recommend that you run concurrent experiments, as otherwise you're not going to scale. I worked at Bing. We initially had a system where you cannot run concurrent experiments. And, there's just not enough power. What are you going to do to test 30 ideas? You're going to give each one 3%. That did not have enough power. So we moved into concurrent experimentation, but you have to do this smartly, right? Even if in the largest sites you never have enough users, and what I mean by you have to do this smartly, I would say there's 2 things that you should do when you introduce concurrent experimentation. One is raise awareness. Interactions can happen. And the first thing you want to do is avoidance, right? Educate people that if they're touching something that could interact, sequence them. But most things do not interact. And by interaction, by the way, it doesn't mean that A and B are both have positive effect. It means that when you put them together, the combined effect isn't the sum, right? So it can be either synergistic or antagonistic, but it's rare. And the second thing you should do is, what we call sort of optimistic concurrency, which is, okay, allow people to launch things that, they're obviously are not overly concerned, but test for that. So it's very easy to run a test for interactions. And when I say it's very easy, you can see here a bunch of references. It's easy to do for a single experiment. It's hard to do if you want to try it for all pairs of experiments. And that's where you have to implement, some control of your error rate, because if you have 1,000 concurrent experiments running, you're going to have to do 1,000 squared statistical tests, right? It's 1,000 choose 2. And so there are ways to do this. There's a bunch of references, and all the big companies have implemented this. I worked at, Microsoft and Google has their overlapping paper in the references, and Airbnb. Everybody's been running concurrent experiments, so you should do it.
We are at the 45-minute mark, and this is just our last questions page, so we're doing really well on time. This question is, we had a lot of questions actually on AI and ML, largely because of what's been happening this year. But here's a couple on that topic. From Microsoft, in addition to experimenting for LLM features, how can we infuse experiments with LLM and AI? And the second one is from Indeed. What do you see as the main connections between experimentation and ML, if there are any?
Yeah, so great final question to end with. And I would say I would really separate classical machine learning from the large language models. For classical machine learning, I think there are two places where there's a great relationship with A/B testing. The first one is to evaluate ML models, right? I think it's critical. Most ML models are developed using some offline criteria where you train the model and then you test it on offline data. It's a good way to increase your success rate, but it's not a good enough predictor of actual performance. So you have to evaluate your ML models. The final determiner is in an A/B test on live users. And there's a theorem, by the way, that says that you can't have a metric that evaluates offline that will actually be correct in predicting the online performance, because that means you can establish causality from an observational study, which we know is impossible. So one good area, make sure you learn about triggering. It may be very helpful in being able to allow you to increase the statistical power as you evaluate your ML model. So in my class, I have a whole section on why triggering and ML work so well together. The second thing where we can use ML is for the A/B testing system itself. So when you run an A/B test, the simplest thing to do is to show you your 8, the average treatment effect. But the next stage is to tell you, look, there are segments here that differ from the average, what statisticians call heterogeneous treatment effects. And that's amazingly good, useful. I think it's one of the most successful features that opened up a lot of interesting insights when we did this at Microsoft. So I hardly recommend that you look at this idea of interesting segments. Now, for LLMs, I think it's early. I have very wide confidence intervals on anything I say here, so don't take this as something that I know much about. But I think I'll give two examples here. One is the A/B testing expert. Okay, and I'm familiar with one that is called CRO Professor. They just build LLM models on a bunch of books, including we gave Dennis, who runs the site, our own book. And then so you can ask it questions. So it's fun. Like they've ingested a lot of CRO and A/B testing material. You can have fun asking some A/B testing questions and use the power of LLMs. The second thing, which I think is really nice, that I think we're going to do more of, is for idea generation. So you're working in a product team, you want to generate some ideas, you start running those against some LLM models, ChatGPT, Bard, whatever, both to generate the ideas and for criticism. It's kind of funny. You can feed these LLMs like a paper and say criticizing, and it's really fun to see how useful that is to help us out. So that's it with the questions. I will, I think, move it to Tim or Morgan to finalize this.
I can finalize this. Just want to thank everyone for attending. We got a couple of closing slides here. The first is Ronny does have an upcoming online course starting on August the 28th. Several folks from Statsig have attended this, and I've also heard a lot of great things from other folks as well. So I do recommend this. If you do sign up, do use the code STATSIGPOWER, and you'll get $500 off. Next slide is from Statsig. We do have a community. If you're interested in joining on Slack, you can find that on our website. You can also follow us on LinkedIn. And if you have any questions for us in particular and are interested in getting started with experimentation, we have an email here for Sami, SAMI, @statsig.com if you want to hear more. But I do want to thank everyone. That was a great set of questions. Ronny, I learned a lot from this, and I think this was a great recap of like the state of experimentation today. So thank you very much.
Thank you so much.
Awesome.